Learning target number 1, understand and find the exact values of inverse trig functions. Let's start by just going back to Precalc 1 when we were doing all the different kinds of functions. We were doing logarithmic, exponential, quadratic, and we found that there were inverse functions in all, and they all had the same kind of rules. One was that some of them had inverse functions, some of them did not, and one way that we tested for that was something called the horizontal line test. That told us if a function was 1-to-1. If it was 1-to-1, it had an inverse. If it wasn't, it didn't. So on the left-hand side, that looks like a quadratic equation. We have no inverse function. It doesn't pass the horizontal line test. That horizontal line intersects the equation at 2 points. So it did not have an inverse function. On the right-hand side, that does have an inverse function, because we don't have any point on that red equation where that blue line intersects more than once. So inverse functions pass the horizontal line test. Functions that do not have inverses do not. Another truth that we came across is that inverse functions are reflections of each other across the line y equals x. All right, so now let's go take a look at what we've been doing with our trigonometric functions. Now you might say right away, hey, I know that doesn't have an inverse function, so therefore let's skip this lesson and let's go straight to 5.8, because you can't have an inverse function. And I would say on the surface, you're right, but I'm going to be sneaky. I'm going to do something here that's going to allow us to have an inverse function to this graph. Here it is. You see what I did there? I restricted the domain of the function to negative pi over 2 to pi over 2. This obviously is quadrant 4, so that would be when sine is negative. And here, this would be quadrant 1, because sine here is positive. If you look on the unit circle, it would look something like this. What we've done is we've said, hey, the unit circle, that's all good and everything, but we only care about values in here. So we've restricted the domain from pi over 2 to negative pi over 2 to pi over 2. And now we've created a function that can have an inverse, as no horizontal line intersects that more than once. That's a better look at the function that has been created. And we have a couple different ways of saying this. Remember when we dealt with inverse functions back in Precalc 1, we had f of, what looks like f to the negative 1 power, but we would say the inverse function of x. We're not going to use that here. We've got two options for trigonometry. We've got y equals and the function, so in this case sine. So that would be read as y equals inverse sine of x. Another way that you might see it too is arc sine of x. That means the same exact thing, arc sine of x. Parentheses, no parentheses, doesn't really. I like parentheses. So that's two different ways you can represent this. As you can see, the graphs, they're kind of interesting what happens with these graphs. It's not superimposed, so you can't really tell, but you can see clearly here that y equals sine of x on the left-hand side has a domain of negative pi over 2 to pi over 2 and a range of negative 1 up to 1. That's inclusive. And the inverse sign, that graph, is going to switch up the domains and the range naturally. So we have perfect reflection. It's harder to see here, but we do have the reflection across the y equals x line, proving that these are inverse functions. Now we're going to find the exact values of inverse trig functions in this lesson. But before we do, I just wanted to do a quick little review. This is what you're used to doing. You're used to being asked to find sine of an angle. So you say sine pi over 3. Okay, well, pi over 3 is in quadrant 1. Looks like this. This is our theta. And sine is the y value, so This is the long leg of that triangle, so that would be root 3. And then this would be 1/2. Oops, root 3 over 2, I meant. And then this would be 1. And we're concerned with sine, so the answer to that would be root 3 over 2. Okay. What we're going to be doing now, though, is inverse sine, and we're going to be given the angle. Okay. We're going to be given, hey, inverse sine, and the length is root 3 over 2, and we have to find the angle that works with that. That's inverse sine of root 3 over 2. And now the answer would be, oh yeah, well that's pi over 3. So we're going to be doing the opposite of what we're used to doing. Or maybe a better way of saying it is the inverse of what we're used to doing. All right, so we're going to try our first one here. Now, you can have a unit circle out for this. I'm not opposed to that, but I would like you to kind of use that to check your answer as opposed to just using that for the answer, because you're not expending as much energy. Your brain is kind of taking it easy. So I'd like you to at least consider solving it for yourself and then going to the unit circle. All right, so let's understand that with the inverse sine function, we're asked to find the inverse sine function. We are dealing with the quadrants 1 and 4. So let me get that out here again. Let's not forget that we restricted the domain to quadrants 1 and 4, negative half pi over 2, and positive pi over 2. Okay, so this asks us to find the angle here, theta. It wants us to find theta of root 2 over 2. Now, let me write that down. So this is sine, inverse sine, sorry, of root 2 over 2. Or I'm going to also write this out in English. Sine of what theta, value of theta, is root 2 over 2. And yet, another way to do this would just be to make it shorter. Sine of theta is root 2 over 2. And we're looking for the angle here. So let's take a look at where we see the y value being root 2 over 2. And I see it a couple points here. I see it here. Right. That's y right there. That's what we're looking for. And I see it here as well. But remember, we have restricted the domain, so this is not included now. So that means our only solution for this would be right here, which is pi over 4. That's the only place where sine, or the y value, is root 2 over 2. You can notice that in the other domain that's not restricted, so in quadrant 4, that value, it's not positive. So that's why the only solution there is pi over 4. So let's recap what we did here. The first thing we'll do is we'll let theta equal our inverse sine function, okay? Then we're going to rewrite that sine function as sine of theta equals x. And it's going to be in between the values negative pi over 2 and positive pi over 2. So here's another example. I just made this one up here. Theta equals the inverse sine of negative 1/2. I'm going to just use my trig knowledge. I'm just going to use the trig knowledge this time. So I'm going to rewrite this as sine of theta, not inverse sine, just sine of theta, equals x. It's just going to be this value here. Well, actually, we've got a value here. It's negative 1/2. So equals negative 1/2. Okay. And now I'm just going to use my knowledge. First of all, I'm going to see that that's a negative, right? And when you're dealing with the 4 quadrants, in which quadrants is sign negative? Well, it's certainly not the first quadrant, right? Because everything's positive there. So that means if I'm restricting it to negative, right, pi over 2, to positive pi over 2, and I'm just restricting it to these, well, it's going to be positive. Sine is positive in this graph, just like all the functions. It's only negative here, so that means I'm going to be in quadrant 4. Now, I've got to think, okay, 1/2, that's a 30, 60, 90. That's the short leg of a 30, 60, 90, right? 30, 60, 90, and 1/2 is the short leg. So that means this is going to have to be opposite the smallest value. So that's going to kind of look like this, there. Okay, and now this would be negative 1/2, right? Because it's going down on the coordinate plane. And that means what angle would be opposite that? Well, you might be saying, well, that's going to be, let's see, that's 11 pi over 6. That might be your first instinct, because it is. But then, remember, it's restricted to these. So that 11 pi over 6 is not within that range. So then you have to say, oh, that's a negative, and it's a negative pi over 6. See how it can be tricky like that? So our answer there is negative pi over 6. The reason I do that is because that's where people make a lot of mistakes. That's where I made mistakes over the years. You've got to make sure that your answer is inside this range because we've already restricted the domain. So 11 pi over 6 would not even be in our domain. Let's look at another example. Normally the checkpoints, I let you run wild on these and then come back and check your answer. I'm going to give you that opportunity, but I'm also going to do this one too, just to get this one down. Okay, so this is what I would do first, is I would just recognize, okay, restricting the domain to, and always doing this with this function with sine, negative pi over 2 to positive pi over 2. And I'm looking for root 3, 2. So sine of theta equals root 3 over 2. I know that's going to be in quadrant 1, so it cannot be here because it's positive. Sine's positive, it's got to be in quadrant 1. It can't be in quadrant 4. Now, root 3 over 2. You remember what kind of a angle ended up with a root 3 over 2? Well, we're looking for where is y a value of root 3 over 2? Well, that would be, in a 30, 60, 90, that would be the long leg. So that would be this one right here, be root 3 over 2. And that would be opposite a 60-degree angle. Right? So theta would be 60 degrees, or a better way of saying that would be pi over 3, since we're looking for the answer in radians. So for the inverse sine of root 3 over 2, that answer is pi over 3. The inverse cosine function. Now you might think, well, okay, let's do negative pi halves to pi halves again. But if we did that, folks, we would have no inverse function, right? That's my best guess here, or my best shot here at a horizontal line, which isn't very good. But that's not going to be a one-to-one function, so we can't do that. So we have to do it over a different period. We're going to be doing it here from, starting from, oh, thank you. Yeah, starting from 0 to pi. Now we have created a function that has an inverse, right? So look at the, if we look here, if I put this down here as well, this is quadrant 1 and this is quadrant 2. So in sine function, or inverse sine function, we were just looking at 4 and 1, but in inverse cosine, we're looking for quadrants 1 and 2. So we're only dealing with quadrants 1 and 2. So this is asking us to find the exact value of the inverse cosine of negative root 3 over 2. So let's start here with understanding this is going to be in quadrant 2, right? This is going to be here. It cannot be in here because that's negative, and cosine would be positive in that quadrant. So we're clearly dealing with quadrant 2. So let's rewrite this as cosine of theta equals root 3 over 2, or negative root 3 over 2. All right, now that's going to be very similar to what we just did. We realized that cosine, so that's the x value. This is the long leg again. Long leg of 30, 60, 90. Cosine is adjacent to that. Cosine is going to be your x value. So that means this is going to be the long side of the triangle. You're going to have the right angle there, and it's going to go like that. So what is this? Well, that is going to be 150 degrees, or in pi radians, that's going to be 5 pi over 6 radians. So the exact value of inverse cosine of negative root 3 over 2 is going to be 5 pi over 6. Okay, your turn here. Find the exact value of inverse cosine of negative 1/2. I'll have the answers when you return. All right, so for this one, I realized that it couldn't be in quadrant 1 because cosine is negative, so it has to be in quadrant 2. I also noticed that 1/2, well, that is the short leg of a 30, 60, 90. So I'm looking for a 30, 60, 90 with a short leg on the x-axis, and I found it. It's right here. This is going to be theta equals 2 pi over 3. Once again, you could do this with a unit circle, if you have a unit circle with you. But I like students to be able to go through this process too, just in case you're in a situation where you don't have a unit circle handy. It's nice to fall back on your trig knowledge. Now, tangent. We can make a tangent a one-to-one function if we restrict the domain from negative pi over 2 to positive pi over 2, much like the sine function. So the tan function will be restricted to quadrants 1 and quadrants 4. If it's positive, it'll be 1. If it's negative, it'll be 4. We're asked to find the exact value of the inverse tan of root 3. So let's rewrite that as tan of theta equals root 3. And let's mark our coordinate plane so we know what values we're dealing with. Now, tangent, like all trig functions, is going to be positive in quadrant 1, and it will be negative in quadrant 4. It's given to us as a positive, so that means it must be in quadrant 1. Now further, let's remember that tan equals y over x. So we're looking for a value of 3 over 1. And if you need the unit circle, fine, but if you remember that looks a lot like a 30, 60, 90 triangle in which the y value will be greater, and that'll be the longer leg, than x, which will be the shorter leg. So that means our x value will only be the shorter one. So it'll look like this. So this would be root 3 over 2, right? This would be 1 over 2. And if we say, hey, what's y over x? Well, we could just reduce that to root 3 over 1, which can be reduced to root 3. So we found it. What angle is that? Well, that's obviously there at a 60-degree angle, and that's going to be 2. I'm sorry, not 2. Sorry. It's going to be pi over 3. So the exact value of the inverse tan root 3 is pi over 3. Radians. I think I forgot to say radians. Okay, next one. Find the exact value of inverse tan of negative 1. Do that, and then I'll have the answer when you unpause. Okay, find the exact value here. What you should have realized is it's got to be in quadrant 4. And when you have -1, that sounds like a 45, 45, 90 triangle because your two legs are the same size. So if you put y over x, well, that's going to be 1. We just have to make sure it's -1, which is why we put it in quadrant number 4. Now remember, the domain is restricted from -pi halves to pi halves, right? So if you're trying to go clockwise, you're trying to go positive, that's going to be outside that range. So we have to get the angle right here. It's going to be a negative angle, and that right here is pi over 4, negative pi over 4 radians. So negative pi over 4 radians is the correct answer for this checkpoint.